Right now, beneath your feet, there is a ball of solid iron hotter than the surface of the earth. And above your head, space is closer than the nearest city. You live sandwiched between two extremes so violent they'll kill you instantly. So let's take the tour. From core to sky, today we go all the way through. Okay, so here is a question that I want you to hold on to. If you could fall straight through the earth in one direction and rocket straight up in the other, what would you actually pass through? Because most of us have this vague idea of hot stuff below and clouds above, but the reality is so much weirder and so much more dramatic than that. We're talking liquid metal oceans, invisible shields, layers of air that hit temperatures colder than the Antarctica, and a boundary in the sky where the rules of physics literally changed. They flipped the script on you up there. Let's start at the very bottom first. And I mean at the very bottom. Our first stop is the inner core, which is about 6,371 kilometers below your feet. That's roughly 4,000 miles, by the way. The inner core is a hot, dense ball of mostly iron with a radius of about 1,220 kilometers. Temperature there is around 5,200 degrees Celsius, and the pressure is nearly 3.6 million atmospheres. Let that sink in. 3.6 million atmospheres. Stop 1. The inner core. It's about 6,371 kilometers below your feet. The inner core is a hot, dense ball of mostly iron with a radius about 1,220 kilometers. Temperature there is around 5,200 degrees Celsius, and the pressure is nearly 3.6 million atmospheres. Let that sink in. 3.6 million atmospheres. And if you were somehow teleported down there, you wouldn't just be crushed. No. You'd be compressed into something smaller than a marble before you had time to scream even. But here's the wild part. The temperature of the inner core is far above the melting point of iron, and yet it is not liquid. Unlike the outer core, the inner core isn't molten. Its own intense pressure, the entire rest of the planet is sitting on top of it, prevents the iron from melting. The pressure is so extreme that it literally forces the iron to stay solid against its own will. It's like squeezing an ice cube so hard it can't melt, even if you hold it over a flame. Nature is insane like that. And it gets weirder. A study in 2024 confirmed that the Earth's inner core had actually slowed down its rotation speed in recent decade, and more recently it has also undergone changes in its shape. The core is literally reshaping itself beneath us, and we only found out recently. This isn't ancient geology. This is happening right now, and this is something that we talked about in the previous video as well. But let's keep moving, because the inner core is just the beginning, and the next layer up is something even stranger. Stop numero dos. The outer core, from 5,150 kilometers to 2,900 kilometers deep. The outer core is liquid, about 2,092 kilometers thick. Both the inner and outer cores consist primarily of iron and nickel and are extremely hot, with temperatures ranging from 4,000 to even 5,000 degrees Celsius. My goodness. So you've gone from a solid ball that's too hot to melt to an actual ocean of liquid metal swirling around. This isn't a small puddle. The outer core is a fluid layer about 2,260 kilometers in height and composed of mostly iron and nickel that lies above Earth's solid inner core and below its mantle. And this liquid metal ocean isn't just sitting there, it's churning. It is the site of violent convection. And that churning metal is what creates and sustains Earth's magnetic field. The whole reason your compass points north, the whole reason birds can navigate, the whole reason solar radiation doesn't fry you alive walking to work. It all traces back to this roiling, spinning ocean of liquid iron 3,000 kilometers underground that you will never ever visit. If you're lucky enough, that is. Earth's magnetosphere shields us from erosion of our atmosphere by the solar wind. Charged particles our sun continually spews at us. Erosion and particle radiation from coronal mass ejections and cosmic rays from deep space. It plays the role of gatekeeper, repelling this unwanted energy and trapping most of it at a safe distance from Earth's surface in twin donut-shaped zone called the Van Allen belts. Without it, the magnetic shield would stop deflecting charged solar wind particles that would otherwise erode the atmosphere and damage life. Without it, Earth would resemble Mars, dry, exposed, and largely lifeless, basically dead. The whole reason we exist as a species is because of what's happening in that liquid metal ocean right now. Let that one marinate for a second. Okay, now we're heading up through rock, and rock sounds boring, but stay with me because the mantle has tricks up its sleeve. Alright, before we continue into this video any further, I just want to share this program that I started recently, and it really helped me relax and focus while I was working. I'll leave the link in the description as well as the pinned comment, and you can check it out. Let's get back to the video. Stop number 3. The mantle. From 2,900 kilometers to just 30 kilometers deep. Below the crust is the mantle, a dense hot layer of semi-solid rock approximately 2,900 kilometers thick. The mantle contains more iron, magnesium, and calcium than the crust, and is hotter and denser because temperature and pressure inside the Earth increase with depth. Here's a fun analogy. You know how glass seems solid but technically flows very, very slowly over centuries? The mantle is kind of like that, except it's rock, and it convects like a lava lamp. When the convection currents flow in the mantle, they also move the crust. The crust essentially gets a free ride with these currents. Every mountain range, every earthquake, every volcano is basically a surface expression of the mantle doing its thing down below. The heat there ranges from around 1,000 degrees Celsius near at the top to around 4,000 degrees Celsius near the bottom. That's hot enough to melt most rocks, but most of the mantle rock stays solid because of the pressure. See a pattern here? In this planet, pressure is basically the bouncer that keeps everything from melting, every single layer. Now here's the number that blows my mind every time I think about it. We have never directly measured the core's temperature. The deepest drill hole reaches only 12.26 kilometers, barely scratching the surface. Speaking of that drill hole, the Cola de Tor, the Cola Super Deep Borehole, the deepest hole ever dug, reaches approximately 7.5 miles, which is, as I mentioned, 12.26 roughly kilometers below the Earth's surface. That took about 20 years to reach, by the way. The Soviet Union started drilling in the 1970s. They planned to go 15 kilometers. They never made it past 12.2. Scientists and engineers were forced to give up when they hit unexpectedly high temperatures at 7.5 miles below the surface. The rocks were at a temperature around 180 degrees Celsius. This was almost twice as hot as they'd predicted. And here's the best part. The hole is only 23 centimeters wide, about the size of a dinner plate. It's deeper than the Mariana Trench and deeper than the Mount Everest is tall. This tiny thread through stone that took 20 years to make barely scratched the crust. We haven't even gotten close to the mantle. We sent humans to the moon decades before we figured out how to drill through our own backyard. Oh, and there is an urban legend that Soviet scientists lowered a microphone into the Kola hole and heard screaming. That story circulated wildly. Some claimed that the borehole had broken into hell. It was a myth born of Cold War imagination. In truth, the deepest sensors heard only the quiet groan of shifting rocks. Not really screams, just the planet doing its thing. Alright, back to our journey. We're rising now, punching through the crust, heading from the surface. So, let's go to stop number 4, the crust. From about 70 kilometers to, well, 0 kilometers to surface. The thickest part of the Earth's crust is about 70 kilometers, which is about 43 miles thick, and lies under the Himalayan mountains. It is extremely thin, cold, and brittle compared to what lies below it. The crust is made of relatively light elements, especially silica, aluminum, and oxygen. Under the oceans, the crust may be as little as 5 kilometers thick. Beneath the continents, it may be 30 to 70 kilometers thick. So when you're standing on a continent, you're on a thick slab of relatively light rock. When you're on the ocean floor, you're on thin, heavy basalt crust. And the difference in density is actually why ocean crust can dive under continental crust during earthquakes. Dense stuff sinks. Basic physics. Planetary scale. The crust is the home of everything you've ever seen, eaten, breathed, or stepped on. Every forest, every ocean, every city, every fossil, every diamond, all of it exists in this relatively paper-thin shell wrapped around a planet that, by composition, is mostly molten metal. We really do live on the skin of a beast. And now we go up up and away. Stop number 5, the troposphere, which ranges from about 0 to 12 kilometers. That's approximately 7.5 miles above the surface. You step outside, you breathe. Congratulaciones. You are now in the troposphere. The troposphere is the lower layer of the atmosphere. Starting at ground level, it extends upwards to about 10 kilometers, which is 6.2 miles above sea level. We humans live in the troposphere, and nearly all weather occurs in this lower layer. Most clouds appear here mainly because 99% of the water vapor in the atmosphere is found in the troposphere. Every storm you've ever seen, every snowfall, every rainbow, every tornado, all of it crammed into this relatively thin layer of atmosphere clinging to the planet's surface. Here is a fun one. Commercial airplanes fly near the very top of the troposphere. You've been at the edge of the weather zone every time you've been on a flight. Above you, clear, calm, frozen stratosphere. Below you, the entire history of human weather experience. But here's where it starts to get really strange. Stop number 6, the stratosphere, which is 12 kilometers to about 50 kilometers above the surface. The stratosphere lacks turbulence and updrafts. Commercial passenger jets fly in the lower stratosphere, partly because this less turbulent layer provides a smoother ride. The stratosphere also has a secret weapon, the ozone layer. It contains much of the ozone in the atmosphere. The increases in temperature with height occurs because of absorption of ultraviolet radiation from the sun by this ozone. By absorbing dangerous UV radiation, the ozone in the stratosphere protects us from the skin cancer and other health damage. So while the mantle and outer core keep solar radiation from stripping our atmosphere away, the ozone layer in the stratosphere is the next line of defense, blocking the UV radiation that does make it through. Earth has layers of protection like perfectly engineered fortress, except the fortress is 4.5 billion years old and built itself from what we can tell right now with current technology. Alright, let's go to our next stop. Stop number 7, the mesosphere, which is about 50 kilometers to 85 kilometers above sea level. Most meteors burn up in the mesosphere. Unlike the stratosphere, temperatures once again grow colder as you rise up through it. The coldest temperature in Earth's atmosphere, about minus 90 degrees Celsius, which is about minus 130 degrees Fahrenheit, are found near the top of this layer. At the top of the mesosphere, it is colder than anywhere on Earth's surface. Colder than Antarctica, colder than the worst winter night you've ever experienced and will experience. And yet, simultaneously, this is the layer where meteors, space rocks traveling tens of kilometers per second, burn up in streaks of light that you call the shooting stars. You are basically watching space rocks incinerate in the coldest part of the atmosphere. Shooting stars and negative 90 degrees Celsius. Same layer. Wild. Now things get really weird. We are entering the thermosphere, where the temperature goes back up, way up, and yet it would feel like freezing cold. How? Well, let's keep going. Stop number 8. The thermosphere, 85 kilometers to 600 kilometers above sea level. Between about 85 and 600 lies the thermosphere, known as the upper atmosphere. While still extremely thin, the gases of the thermosphere become increasingly denser as one descends towards Earth. Incoming high-energy ultraviolet and X-ray radiation from the sun begins to be absorbed by the molecules in this layer and causes a large temperature increase. Temperatures in the thermosphere can reach over 2000 Celsius, but here's the trick. There are so few gas molecules up there that they can't actually transfer much heat to you. Temperature, technically, is a measure of how fast molecules are moving. In the thermosphere, the few molecules that exist are moving really fast, hence high temperature. But they're so spread out, they barely collide with anything. If you put a thermometer up there, it would actually read as freezing cold because so few molecules would hit the sensor. It's one of the greatest paradoxes of the atmosphere. 2000 degrees Celsius and you'd you'd still freeze to death. Now that's wild. Also in the thermosphere, the Aurora Borealis and Aurora Australis form here. The northern lights, the southern lights, when solar particles breach Earth's magnetic field and interact with gas molecules in the thermosphere. They light up in curtains of green and purple and red and make cool patterns. It's the outer core's magnetic field reaching all the way up here and putting on a light show. The planet is essentially showing off at this point, flexing on us. And honestly, fair enough. The International Space Station orbits in the upper thermosphere, roughly 400 kilometers up. Astronauts are technically still inside Earth's atmosphere, just the ultra-thin top end of it. But this is also near where the commonly accepted boundary of space begins. Stop number 9, the Kármán line, which is about 100 kilometers, which is 62 miles above sea level. Now, the Kármán line is widely recognized as the boundary between Earth's atmosphere and outer space, positioned at 100 kilometers exactly above the Earth's surface, named after aerospace pioneer Theodore von Kármán, who calculated that at this altitude, the atmosphere becomes too thin for conventional aircraft to sustain flight. The Kármán line symbolizes a transition where the principle of aeronautics give way to those of space flight. Around this elevation, the air becomes too thin for standard aerodynamics to work, and you must switch from airplanes to rockets. Not only that, but the blue sky goes away, allowing you to see the stars in broad daylight. Although, here's a fun debate, organizations in the United States, including the U.S. Air Forces, NOAA, and NASA, actually use the 80 kilometers boundary, which is roughly 50 miles, as the edge of space. So there's genuinely no universal agreed upon line in the sky. Space starts at 80 kilometers if you're American and 100 kilometers if you're going by international records. Strictly speaking, there is no such thing as an end to the Earth's atmosphere. It becomes progressively thinner with altitude. Space doesn't have a hard wall. It just fades. The sky doesn't end. It gets quieter until it's just gone. And then we get to our next stop. Stop 10. The exosphere. 600 kilometers to 10,000 kilometers, which in miles is roughly 375 miles to 6,200 miles. Now, the exosphere is the outermost layer of the atmosphere. It extends from about 600 to 10,000 kilometers above the Earth. In this layer, atoms and molecules escape into space and satellites orbit the Earth. This is the final handshake between Earth and the void. Gas atoms here are so sparse they can travel hundreds of kilometers without hitting another atom. They're not quite in space and not quite in atmosphere. They exist in a limbo. And some of them that are going fast enough just escape. They leave Earth's gravity entirely and drift off into the solar system. Every day, atoms from our atmosphere are leaving us. Earth loses a tiny bit of itself to space every single day. Slowly, quietly, without a farewell. And then space. The void. Silence. Nothing. The full picture. So let's zoom out. Temperatures at the core range from about 4,400 degrees Celsius to 6,000 degrees Celsius. Convert that to Fahrenheit, that's 7,952 degrees Fahrenheit to about 10,800 degrees Fahrenheit. The surface of the sun, for comparison, is about 5,500 degrees Celsius. You're sitting on a planet with a center that's as hot as a star. Above you, a paper-thin crust. Above that, a thin veil of air hosting all of Earth's weather. Above that, shooting stars and negative 90 degrees Celsius. Above that, the auroras in what is technically still atmosphere. And then, 100 kilometers up, space. The distance from the deepest point of Earth's inner core to the edge of the space is about 6,471 kilometers. That's less than the distance from New York to London. Everything, every layer, every extreme, every piece of the story fits within that distance, and we've never even drilled past the crust. The planet you're standing on right now is one of the most complex, layered, violent, and beautifully engineered objects in the known universe. You just happen to be living on the thin, temperate skin of it, blissfully unaware that a liquid metal ocean is churning below you and the edge of space is directly above your head. That's not just cool, that's the coolest thing on Earth, literally, figuratively, from core to sky. And that's the full journey, from a solid iron ball hotter than the sun through oceans of liquid metal, 3,000 kilometers of churning rock, a paper-thin crust, 5 layers of atmosphere, and right out into the void. This planet is extraordinary. We've barely scratched the surface. I mean that literally. If you want to keep exploring from core to sky, stick around. We've got a lot more planet to cover. Before I go though, just a reminder, that program that I spoke of, it really did help me focus while working, and especially relax after I'm done working. It's an audio program that you can listen to while working or working out or just staring at the wall. It will help you relax. It's pretty convenient. Like I said, link in description, also in the pinned comment below. That's how you can support me without any extra cost to you. Thank you so much for watching this video.